Ever wondered why Albert Einstein called quantum physics spooky? Well, let's dive into this mysterious world together. Quantum physics, often cloaked in intrigue and puzzlement, is a branch of science that delves into the tiniest particles in the universe. It's like the backstage pass to the concert of existence, offering a unique perspective on how the world works at its most fundamental level. Unlike classical physics, which neatly explains the movements of stars and planets, quantum physics dances in the realm of the minuscule. It deals with particles so small that our everyday logic fails to apply. This is where things start to get spooky, as Einstein would say. Particles can exist in multiple places at once, pop in and out of existence, and even affect each other instantly over vast distances. Quantum physics is not just perplexing, it's also profoundly significant. It's the engine behind lasers, MRI scanners, and even your smartphone. So, ready to unravel the spooky world of quantum physics? Hang tight as we dive deeper into this fascinating realm. Imagine you have a cat in a box. Is it alive or dead? According to quantum physics, it's both. Welcome to the paradoxical world of Schrödinger's cat, a thought experiment that gives us a glimpse into the strange yet fascinating concept of superposition in quantum physics. Let's delve a bit deeper into this. Quantum physics suggests that particles can exist in multiple states at once. This is what we call superposition. It's a bit like being in two places at once. In the case of our feline friend, it's being both alive and dead at the same time. But here's where it gets even more interesting. This superposition only lasts until we decide to peek into the box. The moment we observe the cat, the superposition collapses. If the cat is alive, it remains alive. If it's dead, it remains dead. No more straddling between life and death. It's a bit like the age-old question. If a tree falls in a forest and no one is around to hear it, does it make a sound? Schrödinger's cat takes this a step further. If a cat is in a box and no one is looking, is it really there? Is it alive? Is it dead? Or is it both? This mind-boggling concept is a cornerstone of quantum physics. It challenges our perceptions of reality and forces us to question the world as we know it. So, the next time you see a cat in a box, remember it's not just a pet, it's a physics lesson. What if I told you two particles can be billions of light years apart and still affect each other instantly? Sounds like a sci-fi movie? Welcome to the real world of quantum entanglement. Imagine two dancers, perfectly synchronized. Every pirouette, every leap, every step they take is flawlessly mirrored by the other. Now imagine these dancers are not in the same room, not even in the same city, but worlds apart. Yet, the moment one dancer spins, the other instantly spins too. No delay, no signal traveling between them, just instantaneous action. That's quantum entanglement for you. In the quantum realm, particles can become entangled, their states intertwined so deeply that the state of one directly influences the state of the other, no matter how far apart they are. These particles could be at opposite ends of the universe, yet they'd still be connected. A change in one particle triggers an immediate change in its entangled partner. Now you might be thinking, but how can this be? Doesn't this violate the speed of light limit set by Einstein's theory of relativity? Well, quantum physics is full of such paradoxes, challenging our understanding of the universe and making us rethink the fundamental laws that govern our reality. So, entanglement shows us that in the quantum world, distance is just an illusion. Spooky, isn't it? Ever wished you could walk through walls? In the quantum world, particles do it all the time. Now picture a ball rolling up a hill. In the classical world, if the ball doesn't have enough energy, it won't make it over the hill. But in the quantum world, things work a little differently. Imagine that same ball, but now it's a quantum particle. It approaches the hill, not having enough energy to get over it, but instead of rolling back down, it disappears and reappears on the other side. This is known as quantum tunneling, a phenomenon that defies our everyday understanding of the world. Now, before you try running into the nearest wall, remember that quantum physics typically applies to the tiny particles, not to us macroscopic beings. So there you have it, a taste of the mind-boggling world of quantum physics, where cats are both alive and dead. Particles feel each other's vibes from light years away, and walking through walls is just business as usual. Until next time, keep questioning and keep exploring.